Okay, let's look at example 2 of your binomial distribution notes. You've learned that in a binomial distribution, the distribution has to be, you will have two parameters, and the two parameters are n and p. Okay, so from the question, you will need to pluck out these two parameters, their values. So in this question, you're told that probability that a patient recovers from a rare blood disease is 0.4. So it means that P is 0.4. And what is N? N is the number of trials. So in this case, you're told 15 people are known to have contracted the disease. So that means your N or number of trials is 15. So for all four parts of this question, you are concerned about the probability that the number of patients who will survive, okay, after they have contracted this particular disease. So therefore, in binomial distribution question, when we're trying to solve, we will always start by defining the random variable. So we will define x as number of people who survive out of a total of 15 people. Okay, so as the bubble said, how you define binomial random variable is always number of what out of a total of how many. Okay, out of a total of how many will be the number of trials. So in this case, we write, after you have defined, we'll write x can be modeled by binomial distribution with n 15 and p probability of success is 0.4. Okay, in this case, the success is defined as the probability that a patient recovers from that rare blood disease. Okay, so you have also learned previously that the formula for a binomial distribution is as such to calculate the probability, right? So you have learned that it is n choose x times p to the power of x times 1 minus p to the power of n minus x. So in this case, we just replace n by 15, okay, and p, or the p, you just replace by 0.4, and you'll be able to get this formula to help you to calculate the probability of x equals to a particular value, small x, okay, where small x can take on from 0 all the way until 15. So part 1, probability exactly 5 patients survive. That means probability x equals to 5. So in this case, that means your small x in this formula will take on 5. So you just replace all the small x by 5, okay, and you will be able, all the small x by 5, and you'll be able to use your GC to calculate to get the probability, which is 0.186. Okay, part 2. Find what is the probability that at least 2 people survive. So at least 2 persons survive. So that means probability x is greater or equals to 2. So that is equals to 1 minus probability x less than 2, or 1 minus probability x less than or equals to 1. So probability of x less than or equals to 1 is actually the same as probability of x equals to 0 plus probability of x equals to 1. Okay, bearing in mind that for binomial distribution, the random variable can only take on values starting from 0, and it is integer values. So therefore, x less than or equals to 1 means x equals to 0 plus x equals to 1. Okay, so now we can apply that formula to sub in the values. So probability x equals to 0 would be, you just replace the small x by 0. Okay, likewise for probability x equals to 1, so you just replace the small x by 1 in that formula to calculate the probability. Okay, so after that, you can just press your GC and you'll be able to get the probability. Okay, the answer of probability at least 2% survive. Part C, you're asked to calculate the probability that 10 to 12 people survive. Okay, so inclusive. So in this case, inclusive of 10 and inclusive of 12. So probability x between 10 to 12. So it means probability x equals to 10 plus probability x equals to 11 plus probability x equals to 12. Okay, so for each of them, again, we can just replace small x, so the first one by 10. Okay, and then the second one, just replace small x by 11. And for the third probability, x equals to 12, you just have to replace small x by 12. Okay, then after that, just press your GC. Okay, and you'll be able to get the answer. Okay, let's look at part 4. Part 4, you're asked to find the probability that at most half of them survive. So we know that the total number of trials or total number of patients is 15. So half of 15 will be 7.5. Okay, so probability x less than or equals to 7.5. But we know that our random variable x actually is referring to number of people. So in real life, there's no such thing as the number of people is not a whole number like 7.5. So therefore, probability x less than or equals to 7.5, we will write it as probability is the same as finding probability x less than or equals to 7. Okay, that satisfies this inequality, and yet it is and yet this value here, this value over here must be a whole number or integer. Okay, so probability x less than or equal to 7 for if x is a binomial follows a binomial distribution, the values of x, small x will be 0. So 1, 2, 3, 4, 5, 6, and 7. So we sum up all this probability. Okay, for each of them, again, you do the same thing. So let's say the first one, probability x equals to 0. You just replace small x in the formula by 0. Probability x equals to 1, you just replace small x in the formula by 1. Okay, and then sum up all of them, key into your GC. It is rather tedious, but you should still be able to get the answer. Okay, after some calculations. Okay, so you may ask, so if it's so tedious, is there actually a shorter way using the GC such that we are able to actually calculate the probability of all these four parts with just like one keying in of the GC? Yes, we do. So this is what we're going to learn, or what you're going to learn in the next section, 3.5. How are you going to use the GC to calculate the probability for binomial distribution? Okay, so for binomial distribution, using the GC, there are two key GC functions. The first one is called binom PDF. Okay, and the second one is called the second GC key is called binom CDF. Okay, so what's the difference between these two? So suppose we have random variable x, and we know that random variable x follows a binomial distribution with n parameters n and p. Alright, then if we want to calculate probability x equals to x, a particular value, okay, equals to a particular value, then you will use binom PDF. Okay, and the three values we key in into a GC will be n, p, and that small x value that you're finding. Okay, so let me show you the GC steps. Once you're in your GC, you press second vars to get into distribution. Okay, so and you can scroll down all the way until you see a binom PDF. Okay, and click enter. Once you're in, you will be asked to key in three values. Trials means your value of n. Okay, and then P means the probability of success, and small x value means that small x value where random variable x takes on, okay, that you're finding the probability. After you have key in, you just click paste and enter, and you'll be able to get the probability value that you want to find. Okay, so this is the GC steps to find binom PDF. Okay, to calculate probability capital X equals to a particular value. Okay, how about binom CDF? Binom CDF, on the other hand, binom CDF, okay, is used to calculate this one, probability X, random variable X, less than or equals to a certain value. Okay, so take note of the difference between the equality or inequality sign between binom PDF and binom CDF. So in binom PDF, it is an equal sign. Okay, and then in binom CDF, it is a less than or equals for the inequality. Take note, okay, it is in binom CDF, it is less than or equal, not just less than. Okay, so how to get binom CDF in your GC? So likewise, once you enter into your GC, just press second bus, okay, to get into here, and then you scroll down all the way until B, binom CDF, and press enter. And you are in. So likewise, you will need to key in three values, which is your N, your P, and your small x value. Okay, and then paste and click enter, press enter, and you'll be able to get your answer. Okay, for probability X less or equals to a particular value. Okay, so as what I mentioned just now, for binom CDF, the GC only allows you to determine probability random variable X less than or equals to a particular value. So what happens if what you want to find is probability X strictly less than X? Then in that case, we will need to rewrite probability X less than X in the form of probability X less than or equals to X minus 1. Okay, let's look at example. Probability X less than 6. So then we have to rewrite it. It's the same as probability X less than or equals to 6 minus 1, which is also equals to probability X less than or equals to 5. Okay, so probability X less than 6. So what are the X values that it can take on? It will be 0, 1, 2, 3, 4, 5. How about this one? For probability X less than or equals to 5, so the values that random variable X can take on will also be 0, 1, 2, 3, 4, and 5. So can you see that actually the values are the same for both probability X strictly less than 6 as well as probability X less than or equals to 5. So therefore, if you're asked to calculate probability X strictly less than a certain value, you have to change it to the form of probability X less than or equals to a certain value, because your GC key binom CDF can only be used to calculate probability X less than or equals to a certain value. It cannot calculate for all other inequality. Okay, so this is one thing you need to take note of for binom CDF. Okay, so now, just now we realized that in example 2, it is so tedious to calculate, especially like to calculate probability of part 4. So now that you have learned binom PDF and binom CDF, these two keys that you can use to help you to find probability for binomial distribution, let's apply them to find the probability of all the 4 parts in example 2. So in probability X equals to 5. Okay, so how are you going to use your GC? So since the inequality sign is equal, so we will get into here, and then you can scroll down. So we should be using binom PDF. Okay, so what is your trials? That means N is 15, your P or probability of success is 0.4. And what is your X value? In this case, for part 1, your small x value is 5. Okay, and then you click down, and then you paste, click enter, and click enter again. You can see the answer now. So the answer is 0.186. Okay, so 0.186. If you round off to 3, yeah, 0.186. If you round off to 3SF. Okay, so this is how we use binom PDF to help you to calculate when we're finding probability of x equals to a certain value. Part 2, we want to find probability x greater or equals to 2 is the same as 1 minus probability of x less than or equals to 1. So now, how are you going to find this? So for this one, you will be using, since it is less than or equals to, so in your GC key, you should be using binom CDF. Okay, so how are you going to get in? Okay, so likewise, okay, the screenshot is not properly displayed in this on these pages. Okay, when I screenshot it onto OneNote, so you can refer for the exact screenshot. You can refer to your notes, your own notes. Okay, your hard copy notes. So that will be the accurate screenshots of the GC steps. Okay, so now to get into binom CDF, so likewise second vars to get into distribution, and then B binom CDF. Okay, so we want to find probability x less than or equals to 1. So your n is still 15 and your p is still 0.4, and your small x value in this case will be 1. Okay, and then you press enter 2 times and you get the answer. So this is the answer for probability x less than or equals to 1. But what we want to find is 1 minus probability x less than or equals to 1. So we just use 1 minus this answer. Okay, and you get the answer, okay, for part 2 of probability x greater or equals to 2, which is 0.995. Yeah, okay, so 0.995 when you round off to 3SF. Okay, so if you're using so if you're using GC binom CDF, so this will be your presentation in your solution. Okay, so again, let me reiterate, the GC binom CDF cannot be used to find other inequality other than less than or equals to. So therefore, if what you're asked to find, the inequality sign is not less than or equals to, you will first need to convert the inequality sign to less than or equals to before you can apply binom CDF using your GC to help you to calculate the probability that you want to calculate. Okay. Okay. So now that you have learned the GC steps, how to use binom PDF and binom CDF to calculate probability for binomial distribution, let's look at part 3. Probability x between 10 to 12 inclusive of both ends. So I can write it as probability x less than or equals to 12 minus probability x less than or equals to 9. So okay, so in this form, both of them, I can apply binom CDF, okay, to both of them. So, okay, please try out on your own. I will not go through the GC steps again for part 3. So the GC steps are the same as part 2, okay, using binom CDF. So, or probability x between 10 to 12, I can also write it as probability x equals to 10 plus probability x equals to 11 plus probability x equals to 12. If I write it as in this form of equal, then what I should be using would be binom PDF. Okay, versus if I were to write it in this inequality sign form of less than or equals to, then what I should be using in my GC should be binom CDF. Okay, so depending on whether are you using equal or inequality, so that would therefore determine whether you use binom PDF or binom CDF in your GC. Okay, so I leave it to you to go and press the GC steps, okay, to convince yourself that if you were to sum up this 3 probability using binom PDF, you will also be able to get the same answer, 0.0336. Okay, part 4. probability x less than or equals to 7. So in this case, the inequality sign is less than or equals to. So it means you should be using binom CDF. Okay, so just press and again try out the GC steps to convince yourself you are really able to get this answer 0.787, okay, which should be the same as if you were to apply the formula and work out manually, but that will be very tedious. Okay, so in short, the binom PDF and binom CDF can be summarized in this table. Okay, so if we are finding equals x, probability x equals to x, then we'll use binom PDF. Okay, and if that is if random variable x follows a binomial distribution with these two parameters n and p, so if we are finding probability x equals to x, then here it will be binom PDF x. If we are finding less than x, so x strictly less than x, we know that we have to change it to the form of less than or equals to. So probability x less than x is equals to probability x less than or equals to x minus 1. So once we have changed it to this form, so therefore you'll be using binom CDF, and then what you key in as the third value in your GC for small x will be x minus 1. Okay, this value over here instead of x. Okay, how about if the question asks you to find something probability more than x? Then likewise, your GC binom CDF cannot be used to calculate this inequality, so we have to change it to less than or equals to. So probability x greater than x is equals to 1 minus probability x less than or equals to x. I give you an example. Let's say probability x greater than 5. So it is equals to 1 minus probability x less than or equals to 5. Okay, so they are the same. Okay, so let's say x is from 0 to 10. So this one will be values that x can take on will be 6, 7, 8, 9, 10. So it's the same as 1 minus probability of x from 0, 1, 2, 3, 4, 5. Then you will also get x is 6, 7, 8, 9, 10. Okay, so it's the same. Okay, so for this one, if you write it in this form, then it will be binom CDF because of this inequality sign, and then this x will then be over here. Okay, will be over here. So likewise, if you are finding at most x or not more than x, then is probability x less than or equals to x. So since this is already in this form, okay, and this one is x, so over here you use binom CDF, and then it will also be x. Okay. Okay, the last one, if the question say at least x or not less than x. So this inequality sign, we have to convert it to less than or equals to. So probability x at least x is equals to 1 minus probability x less than or equals to x minus 1. Okay, so example, probability x at least 3. So it's equals to 1 minus probability x less than or equals to 2. Okay, so they are the same. Okay, yeah. Okay, so once you've changed it to this form, then this value over here is x minus 1, so you use binom CDF and x minus 1 as your third value that you key into your GC. Okay, okay, so now that you have learned all this, let's look at example 2. Okay, to apply it to a question with context. Okay, so now if this question can be modeled by binomial distribution, we are concerned with number of people who are left-handed. Okay, so we know this is P, but it has to be, we know probability has to be between 0 to 1. So therefore, convert to between 0 to 1. So 20 divided by 100, which is 0.2. You're asked to, in part 1, find a probability that a group of 8 people, okay, so this will be your M, contains not more than 3 left-handers. Okay, so the first thing we will have to do is define your random variable x. So we let x be the number of left-handers out of a group of 8 people. Okay, so um, binomial distribution you always define as number of what out of how many. So x can be modeled by binomial distribution with n 8 and p 0.2. Okay, so these are the two steps you always need to go through. Define a random variable and write down the value of the two parameters for binomial distribution before you start to work out the probability. Okay, probability contains not more than 3. Okay, not more than 3 left-handers. So x less than or equals to 3. Okay, so in this case, since the inequality sign is less than or equals to, so we should be using binom CDF. Okay, no conversion of the inequality sign is needed since it's already in the form less than or equals to. Okay, good. Let's look at part 2. Part 2, you're asked to find least number of people that should be selected if the probability that there's at least one left-hander is greater than 0.95. That means we are finding least n. Okay, so now the number of trials is unknown. So yeah, so we want to find least n. So the number of trials is unknown now. So yeah, so therefore in part we have to define a new random variable in part 2 because in part 1 the value of n or number of trials is 8, but in part 2 we can no longer assume or take it that the number of trials and that the value of n is 8. Okay, so in fact that is what the question wants you to find in part 2. So therefore, since the number of trials has changed, we will need to define a new random variable. So we use x. Okay, we use y. Let y be okay, so let y be the number of left-handers out of a group of n people. So we don't know what is the value of n. Okay, so this is what we need to find out. So y follows a binomial distribution with parameter n and p is still 0.2. Okay, so now what are we supposed to find? So what the question says that probability that there's at least one left-hander is greater than 0.95. That means probability y is greater or equals to 1 is greater than 0.95. Okay, so this is what we are told in the question. So we, in order to use binom PDF or binom CDF, we need to change it to either less than or equals to or equal. Okay, so that's why I can rewrite left hand side probability y greater or equals to 1 is the same as 1 minus probability y less than 1. But because y is a binomial distribution, so y less than 1 can only take on one value, which is y equals to 0. Okay, so now let's do some rearrangement. So to make probability y equals to 0, the subject of this, as in the left hand side of this inequality. Okay, so now once I've changed it to this form, then now there are two ways I can solve this inequality to find least n. Okay, such that probability y equals to 0 is less than 0.05. So the first method will be analytical method or algebraic method. Okay, so that means without using GC. So left hand side probability y equals to 0. Using the formula for binomial distribution, if random variable y follows a binomial distribution, I can write it as n choose 0 and then p to the power of x, in this case small x is 0, times 1 minus p to the power of n minus x. Again, in this case, my x is 0. Okay, so when I write out the whole inequality, so I know that n choose 0 is 1, 0.2 to the power of 0 is also 1, so therefore the left hand side reduces to 0.8 to the power of n. Okay, so the whole inequality will be less than 0.05. So now, to solve this inequality, I can take ln on both sides. Okay, so when I take ln on both sides, this will be what I get. Take note, when I divide by ln 0.8 to both sides of the inequality sign will change direction because ln 0.8 is negative, is less than 0. So when you're dividing or multiplying by a negative number for an inequality, the inequality sign will switch direction. Okay? Okay, so therefore, as your GC, you will get n is greater than 13.4. So you're asked to find in this question what is the least number of people that should be selected or least n. So the least n that satisfies this inequality will be 14. Since n is number of people, so it must be a whole number. So least n that satisfies this inequality will be 14. Okay, so this is algebraic or analytical method without using GC. Okay, so how about if you were to use GC to solve this inequality? Okay, so the GC steps will be as follow. So let me clear this screen first. Okay, so the GC steps, you will go into Y1, okay, and then you will input this binom PDF into Y1. How to input binom PDF into Y1? You will go to second vars, okay, and then as usual, go down to A to locate your binom PDF. Okay, so in this case, your n is unknown, so you just choose x. Your p is 0.2. Okay, and then your x small s value is 0 because we are finding probability y equals to 0 on the left hand side. Okay, and then you press enter. After that, then you go to table. So second graph to get to table. Okay, so your table, if I want it to start from 1, how do I change the GC setting? I'll go to second window. Okay, and then table start, I'll just choose 1. I'll just key in 1. Okay, then I go back to table again. Now you can see. So, okay, x is my n value and y1 is actually my left hand side value that I've keyed in for probability y equals to 0. Okay, so I want to see when is it that y1, the value of y1 first is less than 0. Is first less than 0.05. Okay, so I notice that when I scroll down, I can see that this is when the value of y1 is first, or probability y equals 0 is first less than 0.05. So therefore, this is my answer. It corresponds to x equals to 14 or n equals to 14. Okay, so I copy down this row as the center row in my presentation, and I copy one row above it and one row below it. Okay, so if you are using this method, okay, so how are you going to present? So your presentation will be as follow. Okay, so you will write down using GC, okay, to tell the marker that you have used GC, and two columns. The first column you write n, second column will be probability y equals to 0. So the values of n we know is 14, which is the correct one. Okay, so you will put the correct value of n in the second row. Okay, and then copy one row above and one row below. So from a GC, you can see for n equals to 13, it is 0.05498. Okay, and this value is greater than 0.05. From a GC, for n equals to 14, the value is 0.04398, and this value is less than 0.05. Okay, for n equals to 15, from a GC, you can see the probability of y equals to 0 or y1 is 0.03518. So this is also less than 0.05. So we want the value of the least n such that probability y equals 0 is less than 0.05. So the least n to satisfy that inequality would be 14. Okay, so you write your conclusion. Least n is 14. Okay, so that will bring us to the end of example 3, as well as the end of this video.